Lebanon to learn about AI and to address and to be able to help build the ecosystem in Lebanon and help people in Lebanon understand the power of AI and even consider a career in AI in the future, whether in Lebanon or outside. So we have also a membership program at Beirut AI. So you can, if you are interested, you can always check our membership and apply for it, and you can access all our recordings for all our AI weekends and access member only events that are only for the members and such events as well. With that, then we are part of City AI, which is a bigger network of many communities around the world in more than 60 plus countries. And we are happy to and very proud to be that Beirut AI is one of the most active ones, and actually leading the City AI in, currently in preparing many events and festivals soon. So yes, we would love to have you on board with us. So if you are interested in volunteering and learning more about how to apply AI, we have a lot of positions to volunteer with us, whether it is marketing, whether it is logistics, whether it is university instructors as well. Please feel free to contact us to be able to join with us, or message us on our platforms, or check our website where you can see everything and apply for our positions. So let's start by talking a little bit about AI. So in this, we'll start with talking about what's AI all about. So whenever we think about AI nowadays, we always sadly refer directly to whether the futuristic view of AI or the dystopian one that's really related to either uh, those we see in the movies, Ex Machina and such movies, I, Robot. And we often when this raises the question, is this really AI? And is this really the our perception of AI? But actually AI is very, in our days at least, is very limited to a specific framework that we're going to discuss in a little bit. And for the purpose of clarification, I will be talking today about a subset of AI, which is machine learning. And unlike most people think, machine learning is not equal to AI. Machine learning is a subset of AI, and it's the hottest one in our days, and it's very famous due to multiple factors we'll be talking about a little bit. So whenever we talk about artificial intelligence, we talk about programs that allow machines to process large amounts of data. So obviously we have a lot of sources for data in our days. Recognize hidden patterns in the data, which is something humans are fail sometimes in recognizing, especially in data that's huge or with a lot of features. Also to perform human-like tasks, so imitate humans in the way they do some tasks, as well as learn from experience. So the experience of humans or previous AI experiences, and adjust, which is the most important part, to unseen inputs. So data that we didn't train our AI to, those are unseen data. So we need to make sure that the model is able to, the AI program is able to adjust to this new data and able to perform well on it. So whenever I try to talk about AI, especially the machine learning AI as well, I often try to refer to it as a model, because it's modeling the data that we talk about. So whenever you think you realize that I'm talking about a AI model, so mainly it is the algorithm or the program that we are training. So let's go a little bit and like classify what is artificial intelligence and what is the state of it in these days. So we have three types of AI nowadays. So that were classified nowadays like that. And we have the narrow AI, we have the general AI, and we have the super AI. So the narrow AI is the AI that we have in our stage nowadays mainly, which is made to train, made to for highly specific tasks. So as you will gonna see in a little bit later on today, we're gonna see AI that is being used for predictions of, for example, image classification, predictions of stocks, predictions of prices, and those are very specific tasks. But the moment we were able to see AI that can do multiple tasks, that can be used from training done on learn from one task, and we can be able to generalize and be able to use to other tasks, we can start climbing to what's called general AI. And general AI is when we have an artificial intelligence program that is able to improve the capabilities of comparable humans and have very similar intelligence to humans. So as we can see, humans have multiple capabilities and multiple talents all in the same time. And the moment we start seeing that the AI is able to do multiple tasks all from one training and can generalize to multiple tasks, that's when we talk about general AI. So I'm curious to know if anyone has ever heard of GPT-3. It's a kind of very new news by OpenAI. Can anyone tell me about it? Have you ever heard of it? I nobody heard about GPT-3. I mean, yeah, so it's okay. GPT-3 is a very famous AI model that OpenAI, which is a company used to be funded by Elon Musk previously, is a very big program that was trained for a long time over the whole internet. So because it was trained over the whole internet and for a very long time and over the year, for example, it was able to be applied to multiple tasks. So people in these days are using GPT-3 to generate, for example, recipes, to generate comments, to discuss, to generate chats with chatbots, and much more. So people have been claiming, and OpenAI have been claiming that they kind of started talking about general AI because their GPT-3 model is able to generalize to multiple tasks from their training. But other people are quite skeptical, especially that GPT-3 is very huge and very computationally expensive to an extent that not anyone is able to access it that easy. And once talked about GPT-3 now, once we will be able to move to a higher perspective, which is the super AI, um, once we be able to move once we're able to move to the higher perspective, where we have an AI that have exceeded every single point that we have as a human intelligence, we can talk about super AI. But the thing is that super AI is quite far for now, based on the predictions and people saying, and yeah, it's quite futuristic, but people are quite optimistic regarding it. So by now, are there any questions? I'm quite intrigued to hear your opinions about these ones. Okay, I'm gonna continue then. I'm checking the members and I'm seeing familiar names, Patrick and other people as well. So hey everyone again, and I'm very happy to see you here. Naeem as well. Oh wow, yeah. So with that, then we can continue. And yes, okay. So whenever we want to define artificial intelligence, we have three pillars that are essential to talk about AI. So we have the smart we have we have the need for algorithms, we have the need for big data, and we have the need for hardware. So whenever these three components are together, this helps in developing artificial intelligence programs. So, and in fact, because of the rise of hardware programs that are hardware machines that are very developed and very fast, and because we have a lot of data and algorithms are quite ready for this, that's why machine learning was rising very fast in our days, and that's why it's rising this fast in our days these days. Yes. So because of this mix, we can have the rise of the new algorithms that we are seeing these days, and the fast progress and the fast applications. And we're gonna talk about this a little bit soon. So I'm interested to ask you for this question here. So I'm gonna ask you about, given those faces of humans, I'm quite intrigued. Can you check exactly which one of these are real? There are some numbers above each photo. So please post in the chat which one of these you think are real people, and let's check about that. I'm very intrigued about your analysis skills. Um, yeah, obviously, because we're talking about this in an artificial intelligence workshop, it's quite obvious that actually none of them are real. And those ones are all of them are got from the this person does not exist.com. Is a website where people have generated fake pictures of people using already trained data, and those people, every single picture of these are fake people. It's quite frightening and really concerning that people have that AI has reached this stage of development where it's able to learn this much from people's pictures and generate those new pictures that quite human like, which is very impressive. So yes, and this is not really only one case. We have been seeing that that's a kind of an old situation. I've seen people using applications with deep fakes where they have their pictures and the algorithm will be able to add and dupe some kind of a song to their faces. So it kind of make them sing the same song but with their faces, which is quite frightening and quite scary, the area where have we reached with deepfakes and such approaches. But this is really an important point to show how AI has been advancing and really fast in our days. And the main question is that why exactly now? And AI, if you can check actually in the literature of the artificial intelligence papers, artificial intelligence algorithms have been here since the 80s and the 70s, but they quite went to what we call an AI winter because their hardware was not very ready, not much data was available. And the moment we started arriving to the 21st century and this decade, everything started booming. And we're going to talk about the reasons now. So why now? Um, the amount of data that we have now is very huge, thanks to the sensors that we are having every single thing, thanks to the social media that's recording every single behavior that we have. That that's we have huge amount of data nowadays, and this is really reflecting in the quality of the machine learning algorithms and the many applications that we can now apply to. Another important point is that obviously the social media usage that we are talking about and the improved computational and hardware capabilities. So as you might have noticed, NVIDIA have been going very extensively in developing new GPUs, which are graphical processing units, and those units are being used in training artificial intelligence models, and they're quite powerful and expensive at the same time, and they can help in accelerate, and they are accelerating the training a lot, especially for huge companies, and that's helping in development of these new models. And all of these all of these help us developing new machine learning models. But at the same time, all of these help us to figure out that we need new approaches or revisit the old approaches to process all of these data and produce meaningful insights. So before we're gonna start about discussing every single part, I thought about putting this diagram to showcase to you the bigger importance and the very big importance of people whenever they distinguish between talking about AI and machine learning and deep learning. Because in fact, they are not really the same thing. In fact, every single part is very different from each other, and one is subset of another and such. So AI is the bigger subset, and inside of it, you have machine learning, and inside of machine learning, you have the deep learning part, and you have data science, which is kind of a loose term, which is related to whenever we talk about manipulating data, extracting meaningful insights from data, and it has some intersection with machine learning because sometimes it's important, as you're gonna see in the example we're gonna do together, is that it's important to do some data science before doing machine learning because it's important for us understand the data that we have before we train on it. So yeah, so let's define a little bit of terms today. So let's start by machine learning exactly. So a very interesting case I always refer to is the image recognition task. So has anyone heard of the MNIST dataset previously? MNIST dataset? Anyone? Okay, so the MNIST data set is kind of a data set of handwritten digits. That's kind of the toy data set of the machine learning world. So we always use it for the simple cases, and we always use it for like simplifying the tasks that we have and explaining something very simply. So notice that for every single picture in this data set, for example, we see someone have written a 9 in his own or her own hand writing way, and there is a label for it that says that, well, this picture is for a 9. So it's very important to notice that in every data set that we use, most of the data sets that we use in machine learning, there is a picture or some kind of a data, and there is a label. And the label is very important because it's a crucial part of the machine learning paradigm. So every single picture should have a label. So the 9 has the 9 picture has a label of 9, the 3 obviously has a 3, and the 7 has a 7 as well. And it's very important to start with that. So the thing is that if I give you new pictures, if you came and you wrote your way of writing 9, for example, and you want to detect it, how can we do exactly this? So this is where machine learning comes into place. So machine learning comes in the middle. So in the way that can help us map some data to a specific feature, must in this way here. So if I wanted to do it, if I wanted to do it in the traditional and the image processing way, I would do it and by having some handwritten rules. So if the 9 has some curl inside of it that is related to the circle, I'm sorry, someone was asking something. Okay. And if the 9, for example, if I'm looking and I have some kind of a circle, those pixels have some kind of circles and then a line under it, then that's a 9 for me. And similarly for the 3, similarly for the 7. And if you can, as you can see here, so every single picture has multiple pixels, which are the smallest unit in the picture. So we're gonna do a lot of rules for every single type of picture. But the problem is that those rules, those rules will be a lot, will be many, because there is variations. Every single person will have to write his 7 in a different way. He will have to write his 3 or her 3 in a different way, and that will make our job as writing the if statements a nightmare. Because how can we cover all the variations? And what if we have bigger numbers mainly? So not only from 0 to 10, sorry, 0 to 9, we have 10, 11, 13, 14. How can we like separate these things? And it's even worse. What if we have pixels with for pictures we have colors? So 7 is a color, or not all of them are black numbers. So that raise a huge case and a very important point that relate to the fact that additional approaches will fail when there is a lot of variation inside of the data, where our if statement and hard-coded rules will fail. And this is where machine learning come into place. By the fact that machine learning are easy to train and they are shorter programs, obviously, and they can be used for a variety of cases, we can use them in our case, and they most likely actually to be even more accurate. In fact, there is usually some competitions in machine learning research where they like evaluate the algorithms. The algorithms are always like increasing their accuracies ever since the people are developing new ones, and they have been like always overpassed the traditional ones. So a machine learning workflow usually follows the graph that we have here. So we start by studying the problem, and it's very, very important to do so before even like starting trying any new machine learning algorithm, because as we're gonna see in our example, studying the problem is of high importance, because it will help us understand the data, it will help us understand how biased it is, and such important data that we know. So but when studying the problem, we can start by, and eventually having our insights, we can start by training machine learning algorithms. So when we train our machine learning algorithm using the data that we already have, we evaluate after it our solution. If we are happy with our solution, we launch it. But if we are not happy, obviously we analyze our errors, we investigate our errors, and then we go and we study the problem, we see what we missed, and then we train our ML algorithm again, and so on and so forth until we are happy with our solution. So that's generally the workflow in machine learning. And it's kind of, the more you go into it, you kind of start realizing it's like software engineering where you have multiple solutions. And obviously, people will kind of claim that's kind of subset of software engineering. But yeah, it's starting to morph into like a part where you have to try multiple cases, you have to analyze, then try different approaches, and so on and so on and so forth. With that, then I'm quite curious. Do you have any questions? Is everything clear? Okay. Okay. So in machine learning, once we discuss now machine learning, there are three main types of machine learning domains. And keep in mind that those are until now, because the field is everly expanding, and there's always new things that are being added. So we're gonna discuss every single one of these like in short terms in a bit. So, and this will help us understand our cases here. So we have the supervised learning, the unsupervised learning, and the reinforcement learning. Before I continue, do you have any idea what's the difference between supervised and unsupervised learning based on whatever we talked about now? The name actually is very telling. So, what do you think? What's
In,
your
uh,
theory regarding?
in supervised learning,
Yes.
we insert the data sets that we get. In unsupervised learning, it takes all the data set itself, and we have no say in which data it processes or not.
Um, it's kind of a little bit close to whatever the previous
Supervised labeled
previous.
data.
Sorry.
Supervised learning has labeled data. We know which image belongs to which number, which digit.
Exactly, and that's what I wanted to say. That's the real reason why we talk about supervised versus unsupervised. We're gonna discuss this in a bit, but whenever we talk about supervised, there is always the label. So remember the MNIST where we talked about there is the labels 0 and 1 and 9 for the pictures. In unsupervised learning, there is no label, so we're not supervising the label choice. So the model will have to figure out some insights. Quite interesting, but we're gonna talk about every one of them in a bit. So let's start by the supervised learning. So in supervised learning, we are humans as supervisors for the machine by supplying the labels. So in this example, very simple give, the robot is being taught by the human that look, that's a dinosaur. That's a picture of a dinosaur. And it starts adjusting its learning based on that. And that's another kind of a dinosaur as well. And whenever it has another picture of a different dinosaur or a different thing that's not a dinosaur, um, and the new picture of a new dinosaur says that's very simple picture of something that's very similar to a dinosaur as well. So this way we can refer to this. And it's very important that the supervised learning algorithms are always uh, limited by the label that they have. So we cannot really say that, for example, if you're training a model with pictures of dinosaurs versus pictures of humans, let's say, and you give it a picture of an umbrella, it will not know what will be the umbrella, because obviously it was not trained on labels of umbrellas. But if you introduce the umbrella pictures inside of the data set and you label them, and at that moment the model will be able to learn and say, well, that's the umbrella in that case. So that's mainly a supervised case. Inside the supervised algorithms, there are two domains. Those are depending on the application. Whenever we talk about classification, we have our classes, our data labels are classes, so they are very specified and they are discrete. So in the example here that we have spam and predicting whether we have some emails in your Outlook, for instance, if they are spam or not spam. So it's very specified. We can know that the email that we're going to do predict is either spam or not spam. It's not like 07 spam, for example, or like something like a measure that is not discrete. But that's the other case, which is the regression. In the case of the regression, our label is quite continuous. So let's say in the case here that we talk about the GPA of the students. So obviously our GPAs as students is usually from 2 till 4, for example, at least in my university. So you can have any single value between 2 and 4. So the range is quite high. And that's where we talk about continuous values, and that's a regression task. So classification is for categorical labels, and regression is for numerical labels. So I'm gonna ask you then now a small question, and I'm gonna check if you are understood the difference. So I'm quite curious to know what would be the case if I'm having stocks and I'm interested to predict the prices of these stocks. Is this a classification or a regression task?
Regression.
Yes, exactly. That's a regression task, obviously, because prices of stocks are quite varying and they don't have very specific labels. So now, what about the case for Boston? If I am in real estate and I'm interested as well interested as well to predict the prices of the places that I'm interested to go to. So I have a new house, and given the factors, I'm interested to talk about a new price for the house. How can I evaluate it? Is it a regression or a classification? Obviously as well it's a regression task. Yeah, I will not talk about give an example of regression than an example of classification. It will be very obvious. Yeah, so can you give me anyone interested to talk about an example in classification, a different example other than the spam no spam emails? Yes. I agree, Theodore. Sentiment analysis. So we're gonna have an example in a bit where we talk about that the Twitter algorithm mainly have some sentiment analysis for every kind of a talk, every tweet. So if you have, for example, if you have some people that are talking hate speech, for instance, it will classify that that's a hate speech or not a hate speech. So that's one thing. Whenever it's appropriate or inappropriate, for example, or in Amazon, for example, where we have reviews that are either positive, very good reviews of the product, or negative, or even like levels of positive and negative, very good, medium, neutral, negative, and so on and so forth. Thank you, Theodore, for the examples. And with that, we can move then to the next step. So we talked about supervised learning. So now we can talk about unsupervised learning. So similarly, in unsupervised learning, there is data, but the main difference is that there is no labels. And this might be limiting and quite disappointing for some people that we don't have the labels. But in fact, unsupervised learning has a lot of applications, and we're gonna explain a little bit in a bit now. And this is very simple example. So given that you have those shapes, and imagine them, every single shape of them is a kind of type of fruit, but you don't really know the fruits. And you have, for example, apples and bananas and strawberries. So I came and I told you about that. I want you to cluster those fruits based on their colors. So what I do is that I come and I start evaluating the similarity, for example, between those fruits and say that, well, apples are red in that case. And I have some apples that are red and I have some strawberries that are red. So, well, I can put them in the same group or what we can, or we usually call in unsupervised learning clusters. So we can put the apples and strawberries in the same place because they are those apples are red, for example, and bananas because they are yellow. I will put them in a different cluster, and I will gonna put as well green apples in a different group or cluster, and so on and so forth. But because we have restricted our measurement of similarity between them to the shape, I'm sorry, to the color, I can also come and change the metric of similarity and do, for instance, size or like shape. So obviously, I'm gonna put all apples in one group, all bananas and like elongated bananas or cucumbers in the same size in the same one because they are all elongated, and strawberries, for instance, in a different cluster because I never seen a fruit that looks like a strawberry as well. Maybe inverted here, for example, but no. Yeah, so there are some groups similar. So the beauty in unsupervised learning is that it can help us to extract some meaningful features, meaningful insights of the data that we didn't see. So one interesting example in it that is, for example, if you are, for example, buying some stuff online, whether through AliExpress or Amazon or something like that, your behavior, your buying behavior is very unique to you. But some algorithms on unsupervised learning can use your behavior to cluster you inside a specific group of people of similar behaviors. With that, it can then recommend to you new products that you are more likely to buy from your group. So let's say Theodore really likes photography stuff. So he likes cameras and stuff like that. So he buys a lot of products that are from AliExpress related to cameras. So the algorithm will start to cluster Theodore in the group of people that buy cameras and other things, and it start recommending things based on the same groups, such as tripods or DSLR lenses. So yes, so like the things that are related to a camera. Similarly, it turns out he does not like cameras. He likes robots. So if he buys also robots, he will be clustered in the group of people who buy not robots, microprocessors or microcontrollers, and we start recommending, well, look at this microcontroller that, well, this is new Raspberry Pi, this is a new Jetson Xavier from NVIDIA or whatever, and this is a similar case. So that's one interesting example. And there is a lot of algorithms for unsupervised learning, and they can be used for multiple cases. Okay, so another type of machine learning algorithms that's very famous nowadays is the reinforcement learning algorithms. It's very used nowadays and for games. I'm sure you have seen AI playing games like Dota or like StarCraft, Warcraft, and StarCraft was it the name? Yes. And for instance, here's uh, Pac-Man, and it's a new kind of a beast of AI because it's got quite framed in a different way. So given we have this environment where Pac-Man is playing the game, Pac-Man and every single step he has to do in the environment, he is having a choice to go either up, down, left, or right, right? So and every single step he has to figure out where to go. So if he chooses to go to the left, for instance, and go to the left at that case, he will start eating those small dots, and he will start getting some scores. And those scores are given by the environment, the game itself. So whenever the agent, which is the Pac-Man, is giving some actions to the environment at every single step, it's returning to the environment is giving him some insights around its surroundings. So if there are some dots nearby, if their ghosts are closing very close to it, if there are some those big dots that arrive that says you have a power up, and as well it will give him something very important, the reward. The reward is mainly what drives the reinforcement learning agent to learn. So in this case, we can make the reward to be the score. So Pac-Man will have to maximize its score. Reinforcement learning algorithms are framed in a way that they always want to maximize their scores over the long run. So Pac-Man will have to maximize its score in order to learn and win the game. So obviously in this case, it will have to learn how to how to like do its best behavior to not be killed by the ghost, to eat all the dots and so on and so forth without dying. And it's quite of a complex machine learning framework. It's really recent and it's only gaining traction in the last couple of years, but it's really improving and it's being used in many cases. It has been used as well, not only for games. Google has used it in improving their energy consumption, optimizing their energy consumption in their server units, and so on and so forth. And there are other places as well. So Theodore is asking, are genetic algorithms a type of reinforcement learning? Not really. They kind of optimize the same objectives. So they both optimization algorithms mainly. Both of them want to reach a solution where it is maximizing something or minimizing something, but they are different in the way they do it. So they are different in the way they do their training. So it will deserves its own workshop. Reinforcement learning algorithms try to predict some values for the next steps and use those values based on previous steps to be able to figure out the next step. Genetic algorithms are quite different because at every single simulation, for instance, of the whole environment, you have to select something, some agents, kill other ones, and hybridize some of them, and so on and so forth. It's quite different, but they both are optimization algorithms. Is that clear? Do you have any questions so far? Am I going fast? Should I slow down? Is everything clear? Okay, I guess everyone is satisfied. Okay, so once we now covered the three types of machine learning algorithms. And with that, we can move now to the next step, which is data science. So data science is quite a huge field and it's quite a buzzword sadly nowadays because everyone now will talk about themselves as a data scientist or because he or she will be doing a specific task. Thing is that it's very important to understand what does the data science contain inside of it, and how can we frame it into our work itself. So inside of data science, there are multiple steps, and especially in a data science project or a machine learning project, there are steps that we want to follow. So this is the life cycle of a data science project, or mainly here it's a machine learning project, and we start by, as I repeat myself now again, we start by understanding the need or understanding the program, the project that we have to do. So one interesting thing is that let's say that I'm interested to predict pictures of defected parts in a specific manufacturing company or something like that that are going into the belt. So the business person will come and tell me as a machine learning engineer or a machine learning scientist that, well, I need you to this is the data of defected parts, and I need you to train some kind of a machine learning algorithm to detect those parts and maximize and minimize anything that might be misleaded by the machine learning. So I can maximize the accuracy, let's say. So I came and I understood the business problem and I framed it properly that I can do it as a machine learning problem, and it's supervised. Because why? Because I have labels of the defective parts and I have pictures. So once I have done that, I will again go to the next step, which is data mining. So by data mining, I mean in this case, whenever I do not really have a lot of data, for instance, and I have to look for other data pictures, for instance, in that case, online or in other sources or data sets. So it turned out that in the plan that I'm working on in this example here, the pictures are not a lot. So they're not very, they are few. So I came and having the knowledge in machine learning, I will say that this data will not be enough to like generalize really well for the model. So I will have to like look and mine for new data. So I'm gonna go and scrap Google search, go and look for data sets of people have done the same thing and generate all of this data and get it with me. Once I have all this data, I will go to the third step, which is data cleaning. So data cleaning is a huge part of a data scientist workflow because sadly data is very dirty, quote unquote. So it is not, sometimes it has some wrong labels. Sometimes if you are dealing with not pictures like table or data, some data are missing, so we have to delete those data rows, for instance. Sometimes the data itself has some weird values. So for instance, age will have, for example, a wrong age which is 1000, so we have to delete that row. So it requires us to do a lot of analysis and data exploration, which is the fourth step. And once we figure out that our data is clean and we explored and analyzed our data effectively, we can move to the next step, which is feature engineering. So I will not go into details here. It will become apparent when we do the example. But sometimes some features are not very ready to be fed to a computer program, such as strings, for example. If I have, for example, gender for people, male or female, it's very hard to give this as a string. It's easier to map it to 0 and 1 and say that 0 is male, 1 is female. And then by doing that, I can feature engineer the case in our case, in that case, and frame it in a much better way to be fed to a model. And once we are prepped everything, we can move to the next step, which is predictive modeling. So predictive modeling is mainly trying algorithms and multiple algorithms and seeing which one of them is working and evaluating them using the metric that we chose previously, in our case here, accuracy of pictures, detections. And then once we are confident enough in our results, we go into the data visualization cycle, visualization step. So I come and prepare my plots. I prepare my pictures with proper labels, predicted labels, and then go to the business person and show him show him or her the example, and they will be happy with it, hopefully. And if they're not, we'll continue in the same process of reframing our problem in a different way. Maybe our metric was not the best, and so on and so forth. And that's mainly. If you didn't grab the idea really well, don't worry. We'll go through this example again when we do our example, the coding example that we're going to do in the end today. Okay, so data processing is kind of related to data feature engineering and data cleaning. So it kind of have everything that's related to removing the data that's duplicate, missing, incorrect, put multiple data sets inside of one data set, transforming data to a same scale, reducing unneeded data rows, and so on and so forth. So that's the data processing step. What happened? Yes. The exploratory data analysis step is the step that we already talked about, where we showcase and understand the data we have, whether through plots, graphs, summary statistics, and what you can see here, bubble plots in the lower corner, or two-dimensional plots and histograms. There is so many ways to analyze our data, and you're gonna see that whenever we go into our example today. And as well, feature extraction. Sometimes some features are not very meaningful because for instance, some features will not be relevant. So let's say that we are assigning an ID for people. It does not really, we're not really caring about the IDs in training a model, because the IDs are quite unique to every single person to an extent that are not meaningful. So we remove them. So extracting important ones from the data, transforming the input data into distinctive features. So as we talked about strings of genders from male to 0, females to 1. And there is a very important thing to note here, and I'm talking about it at the third point, is that sometimes we need some expertise in the field itself to understand the data that we have. So sometimes we have data from medical field, and it's very hard for us people coming from a computer or scientific background, computing background, to grab some informations, for example, about the medical data itself, records. So this where the interdisciplinary nature of data science comes in, where we do meetings and like synergies with people of different domains, and we can help each other to understand the data that we have and improve the field. So yeah, so this is an example when I'm talking about here, the same thing about health. So relevant feature for a certain disease can be related to the fact that what is exactly the disease. It might be related to blood pressure or body temperature, but not person's height. But that would be for a specific disease. And me as a data scientist, I will not know that, well, for this disease, these are some important factors, but for another disease, they're not. So that's what I'm talking about here. With that, then we can move to the predictive modeling topic, and it's very the modeling part of the cycle, and it's very important. And I need to highlight this very, very clearly: is that whenever we talk about a machine learning algorithm, at least for the supervised case, we always feed our training data as the features and the data that we have, and then we have always the labels for the training data. We feed both of them to the model, and we get a trained model in that case. And whenever we want to launch it to a new type of data that does not have labels, these are the new data, the unseen data. We feed the new data to the model, and the model will predict, in that case, the new data, the new label for that case. So yeah, it's very important to know this difference because we're gonna use this in our example. Okay, so now that we have covered the differences, we can check now some use cases. Maybe we can discuss them a little bit now. So we're gonna start the applications of AI, and one very famous one is obviously self-driving cars. I could not help but keep this here. I always like try to shuffle the examples, but like so being used nowadays and like very hot topic to an extent that I decided to keep it. So many companies nowadays are using self-driving cars, whether it is Tesla or Waymo, the daughter company of Alphabet, is the same group as Google. They're using computer vision in many tasks in their approaches. So whether to detect the surrounding of the car, whether it does have anything in front of it, some people crossing, animals crossing in front of it, or other cars, they're using computer vision and machine learning, deep learning models to detect that, well, that's a picture of that's a human, that's an old person, that's an animal, that's another car. So it helps in detecting collisions in that case. And that's one very simple example. There is other ways as well where they are framing reinforcement learning itself to help the self-driving cars and optimizing their behavior to reduce, for example, accidents, or like optimize to reduce their energy consumption, and so on and so forth. Another example is Facebook. Facebook algorithms are advancing very fast. Facebook has its own AI lab where they talk about implementing new features and such algorithms. And one interesting thing that I wanted to talk about here is that how Facebook is helping some people who are not able to see the pictures to see actually the pictures by labeling those pictures automatically, and then obviously using some sound generation to talk about those pictures. So because Facebook has an access to huge data sets of people's pictures and labeling them whether manually or like automatically or other ways, they can train their algorithms to actually, whenever you get them a new picture, it will detect what does the picture contain inside of it and predict exactly what is it inside of it and help you see if you cannot see exactly what is inside. Another example is Alexa or any type of virtual assistant, whether it is your Google Assistant, Alexa in this case, Bixby, Siri, whatever. They all have multiple ways of applying AI, whether it is voice recognition, the way they are cleaning and pre-processing our text, whether it is the transformation from speech to text or text to speech. It's using AI extensively because we have many voices as humans, and we have patterns in our discussions with and like many dialects of our ways of talking. So this is very important because they are using these approaches in that way to help ease many applications. And yeah, that's what I was thinking about Siri and Amazon Alexa in that case. And one interesting example for all people interested in arts and entertainment, AI is being used extensively in that area as well. So there is this kind of this new famous thing that's called neural style transfer, where you have a picture of something. So check the picture here, like the A picture of a picture in Czech Republic. So and you bring a new painting of some famous artist. So, for instance, in the picture C here, you get the Starry Night by Vincent van Gogh, and you get this picture, and you want to apply the same style of Vincent van Gogh to your picture. So use style transfer, and it's kind of a advanced deep learning algorithm where it applies style transfer to your picture, and without even having the artist himself, who has been dead for a long time, apply the same thing, but you will be able to use the same thing because your model has been trained on many pictures and many types of styles to be able to learn how to transfer. Or whether here the scream, so the picture of the scream, which is D, and you apply you apply to your picture, and voila, you have your new painting, which is very similar to the style of the first person have done it, but in your way. That's unique to you because that's picture you have took yourself. So it's very impressive and it's crazy. And people have been using many style transfer algorithms to many approaches. Some people have been using style transfer to like alter the picture of the Mona Lisa, for example, and like make it in a different faces and very weird faces and funny faces to their for their entertainment. Another interesting example that I wanted to talk about, we talked about the ranking tweets. I'm gonna skip it because we talked about it. That I want to talk about is this one, the predicting treatment. So actually, AI is being used extensively in medical field nowadays. It's still a little bit slow in being deployed because people are afraid to like, how can I give my data to these companies? What will happen in that case? Am I really sure? Will the model give me something bad? Will I die? Whatever. And there's a lot of questions, but AI is being deployed, is being used, researched very extensively to remove those fears, in fact, and to keep the human in the loop, we call it, because we want to include the human always in the loop. We're able to evaluate the solutions of the machine learning algorithm. So, in this example, when we talk about GNS here, this company has many records of people and their reactions to drugs, specific drugs, and medicine. So they're using machine learning algorithms to given new people's records how they would be reacting to this drugs, and this will help like and reduce any type of risks or allergies, side effects, unwanted side effects. And it's a huge field because now obviously you can know that you can have multiple drugs for the same ailment or same illness. So the thing is that you can some of them will make you feel miserable and will make you feel very bad and will not be very good for you, while other ones will not be the same. So this will help you in evaluate the company, especially in evaluating what would be good for their customers, so on and so forth. So there are multiple challenges, and this will I will recap mainly here talk about that. Um, uh, sorry. There are many challenges, whether it is the domain specific expertise. We'll talk about that. Sometimes we cannot, as scientific people from computing background, understand some problems, but hence the synergies are very important between multiple groups. And data as well requires sometimes a lot of cleaning and pre-processing. So not always data is very clean to be used in multiple cases. And sometimes that's one important case. sometimes we have data from different sources, and you have to like act accordingly and how to mix them. Sometimes data is not free, and data is sometimes it's an issue I face in my research where some data sets are only accessible by big universities because they're so expensive. Scalability and how a model can generalize to new data that haven't seen is still a big area of research and the area of in what's called machine learning, ML ops, machine learning operations. So yes, and how the decisions by these models are being happening. So one interesting example I always say here is that whenever I talk about this, let's take this thought example. I couldn't remember if it's a reference to a new an example I have read a long time ago, but the essence is important. Is that imagine that you are training a model to detect the ball in a football game and to know whether well it's entering the net and well it's a goal or not. So if you come and take pictures of the ball being played with and eventually label that well that's a ball and so on and so forth, sometimes you cannot really interpret those decisions. So you cannot really know how exactly this model is able to do that. But some new tools are helping in that case. So one interesting thing is might happen is that the model will when it's trying to predict that's well that's a picture that's a ball is not really always detecting that's a ball because it's spherical, but sometimes it's that's a ball that's spherical because it's very close to the human foot. So there is a foot always very similar, very close to the ball. So then whenever there is a foot, sometimes the algorithm will might misclassify and say there is a ball here, but there is not me a ball. Why? Because the algorithm didn't generalize well to understand that a ball can be a ball by itself and be sphere and spherical by itself without the need of a foot that's like always close to it. So that's a very interesting thing to think about because it can be generalized and can be moved to like multiple cases, and it's a very huge area whether to understand exactly the models how they are predicting and whether they have some biases and so on and so forth. And this as well leads to one of the most important parts, data privacy. It's not very clear in Lebanon or like in MENA region as well data privacy, but in Europe they take their data um, very seriously because they really care and they get afraid about giving the data to companies, especially in the financial and medical sectors, and this can delay the research. But new approaches are being used nowadays to bypass this and do training machine learning models with privacy as well. So with that, I end with this quote by Stephen Hawking, which is it's kind of thoughtful and keeps you thinking about it. So he says that AI is likely to be either the best or the worst thing to happen to humanity. And with that, we end our talk today. We have a coding time that we're going to discuss now. So thank you for your time, and I hope if you have any questions, please don't hesitate. We have quite of time now as well, and make sure to connect with us on social media. And I'm open to questions. Anyone? Any general questions regarding AI before we move to the
Thank you, Anis, for the insightful talk. I wanted to ask a question about the last point you were mentioning about privacy in Europe. So I've heard that they're trying to implement legislation that prevents the application of AI in specific fields, like getting a loan or not, or assisting judges in their court rulings, or even applications for refugees or immigrations. So do you think that this will stifle the field of AI in a way, or does it go hand in hand with it in a way? Like does it help it does it help it move humanity as a civilization in a better direction? These regulations and limits on the applications of artificial intelligence.
Okay, so I have 2 points to mention here as well. I agree with you. So yes, so the first thing is that I have been discussing this with my friend here, Nasrin friend here. He has been talking that he notices that although like the US, the EU is very like diligent and like very serious about like preserving their data, they're still very slow in their legislation regarding machine learning itself. So the GDPR, which is their protection, the data protection framework for like cookies and whatever things online, is quite bad in a few years. But other than that, their legislation for machine learning are quite slow. So yes, so from one side, this is can like help some companies like accelerate their work and like try to do this before training, before like this new legislations comes. But at the same time, I kind of find those new things, new approaches, to be fair, to be honest, because the way machine learning is being applied to every single field in these days, and the way they are being applied without even thinking about the ethics, in many cases, not going to talk about all the cases, it's quite sad and it's quite unethical. So it's about time that the companies like governments come and agree on like ethics of AI and how they can use their power to define ethics in AI and what can be done and what cannot be done and such and about that. So companies are trying to, such as big companies, like huge companies such as Google and Microsoft, have been trying their best to like integrate ethics in their workflows. So AI ethics, so including, so for instance, Microsoft has in its Azure platform online some pillars that they are using, that AI should not do harm, AI should not do that, AI should be privacy preserving and such and such. So anyone will be caught using Azure, for instance, for like things that are not privacy preserving or not bias or like harming people, will have his applications disabled or something like that. Google itself has its own AI ethics board, so it's trying its best to like try to how can I say, to balance their work with the ethics, but it has a lot of catch uh, catch up to do with the field, because the field is advancing very fast, and sometimes the field is advancing very fast and it's keeping the ethics behind. So 1 month ago, there was no, 2 months ago, there was this very huge scandal at Google, where there is this ethics director in their group where she was fired because she was trying to like leak some data or like some information that their new model, the Switch XL, which is like the very famous last one, which is very huge, has some bias for like minorities and people who are underrepresented. So she wanted to leak this because they didn't let her to stop or like let them reevaluate their approach, but she was trying to leak it. So she was fired, and like 1 month after it, another director or like another in the AI ethics department was resigned, and it quite tells about how troubled is the ethics AI field now. But it's developing. I'm not pessimistic, but it's developing, and I say that the fact that should the government start pressuring this stuff is quite important, because will help move the field of AI from like putting AI haphazardly to anything, to moving to AI that is privacy preserving. So there is this new approach of AI that's being done that's called federated machine learning. It's very famous for its way it's being used for its privacy preserving, and it's very like catching now in our days and becoming famous and famous. So yeah, I kind of find that it's two-edged, but I'm quite optimistic by the way it's developed.
So there is an
That answer your
opportunity
question?
in the, yeah, definitely. So just to add on to your point, there is an opportunity in the AI market or in the AI field in general right now to have more of a focus on ethics and more of a focus on supervising the applications of AI,
Yes,
other than just developing AI models and stuff,
yes,
just
and even
to give
there
more
is a
insight
focus.
to the participants.
Yes,
Yes,
exactly.
you were saying?
And there is even some new companies. I'm sorry, and there is new companies that their whole purpose is to create machine learning models that are privacy preserving. I've been reading about a company in Berlin that's called Aferis. So Aferis is like a new company that's using machine learning in a federated fashion. So by doing it in a federated fashion, it's privacy preserving and it's being applied in medical record. It's still a startup, but it's catching up and it's quite seems to be in the right direction. So, yeah.
Okay, thank you.
Thank you for your question. It's a very important topic to discuss, but yeah, it's quite thorny. Okay. With that, then we can move to our Google Drive. I'm sorry, to our example, coding example. So I would like to ask. We're gonna send you this link on the chat. I would like to ask everyone to get prepared so we can work on our work today and our collab one. Yes. So let me check. I'm gonna change my screen. Okay. So I would like everyone to copy the link here, and by copying the link here, then to uh, enter. Check this page. Can you see my page now? Okay, so as you can see, our task will be related to medical cost prediction today. So it's for insurance cases. So we have our code that's already full. So you can get it for your reference here, but we're going to talk today with the blanks one. So I would like to ask everyone is to go to this link, copy and write Google Colab and open this. So for anyone who has not used Colab previously, Google Collaboratory is a kind of ingenious software that Google has made access to everyone, where they can access GPUs and CPUs online, and they can train their machine learning model over it for free for a limited time. And it has everything set up for you to start your project directly. So you can like try directly to enter some libraries are already there. You can use Python, you can use R, you can use Julia, and and train like investigate your data in a notebook fashion. So we're gonna do that here. So now we have this. We copied this link, um, and let me remember if I can do that here as well. Let me get it. So sorry, it's a different way. Okay. So yeah, I was gonna reiterate about that. No need for opening a new collab. So yes, so copy this link and put it in the tab and open this collab. It's very important that you press file and save a copy in your drive so you can copy and write on your drive itself and have your copy in yourself in your own Google Drive and not write on this copy that we are using here. So everyone, please confirm that you saved it in your drive. So to repeat, file, save copy in drive, and you are ready. So with that, we finished. With that, we are ready to start writing the code. Is everyone ready? Please say yes if you are, so we can move. Make sure that everyone is following up. Okay, okay. So the task that we are having here is medical costs. So we have a small data set of insurance data of people with those columns, and we want to predict what are the medical costs billed if the health insurance something badly for them and how much they would be expected to pay for this person. So why it's kind of interesting. And notice here that we are calling, we're having those columns, age, sex, BMI, children, smoker, region. Every single one of these is we'll call it as a feature, and our target label is a charge, the medical cost built by this. So can anyone tell me, is this classification or a regression task?
Regression.
I suppose it could be
Exactly.
both.
What?
Like it could be regression, definitely. And no, we can fit it. We can fit the numbers to a curve.
The stocks we're
It can
predicting
also
it
be
was
classification if we have brackets of prices.
Here it will be because we're talking about costs. We have like costs that are very specific. It will be a regression task. But again, as you see, it can be framed. It can be framed as a machine learning. It can be framed as a classification task by making classes of costs, so high, low, and so on and so forth, or like ranges. So range one will be the people who are paying a lot of, for example, أكثر من $50,000, for instance, and other things like very high and very low would be less than $100, and so on and so forth. Okay, with that done, we can move. We can continue. So here, notice that we're talking about the libraries we're going to use. So we're going to use a library called NumPy, which is used for manipulating matrices and scientific computing mainly. And we're gonna use pandas, which is a library used for like data analysis and manipulating and visualizing the data. Matplotlib as well is being used here, which is a library used for plotting and visualizing data. And scikit-learn, which is the brain library that we always use for machine learning algorithms and simple classical ones that we're going to talk about here. And I'd like to tell you how to run a cell. So here the fashion is that you have to run every single cell in the same order, so it gives the proper order, the proper outputs. So in order to run a cell, you press on it. Then there is this small triangle run thing here that you press, and it should run. At the first time, it should take a little bit time to connect to a runtime. And now it should be running. And no, here it's showing a 1, so it was run the first time. Another way you can do it is that I will not press always this. You can always press Control Enter while you are inside the cell. So Control Enter will help you run it fastly. So the first thing we're going to start is by downloading the data and getting the data itself from our GitHub repository. Zach has a repository, and it should be running very fast. Then let's start by visualizing our data. So in our case here, I would like to ask you to go and check what can we read a CSV file in pandas. So if anyone can find the function online and tell me, so we can do it. And put it on the chat so we can discuss it. Exactly. Thank you, Patrick. It is read CSV. So PD, which is the pandas library, has a special function called CSV. So PD, and we have to put the file name inside of it. Already we have put the path for it up, so we can always directly say it. And in order to display the first 10 rows, we'll use a function called head. Obviously, the 10 first rows. So let's run it and see what will happen. So as you might notice here, we showed the first 10 rows, and notice that we call every single column a feature, and notice here that the charges are quite continuous. So you have many different variations. So that's in our case, unlike what you were thinking, Theodore, it will be a charge. It will be a regression task in our case. So Yes, and notice here as well, we'll be continuing that here in a bit. Another thing is, thank you as well for like writing the task. It will be easier. Thank you, Theodore. Okay. Yes, the next would be how to count how many rows and columns we have in our data set. So can you please look for the function that gives you the number of rows and columns inside of pandas? Quite easy. Okay, so I guess I can would like to say it. So it's shape. So shape return a tuple, which is a small array mainly, and because in the shape itself, this the first element is the rows, so we index the first element, and the second element is the column, so we index the second element, which is the column. So let's try and run it. So obviously here there are 1,338 rows and 7 columns. So that quite tells us that we have like this much data and the size of the data itself and how many features we have. And another function, interesting function that we have in pandas is info. Info's way is to info's role is to help us understand some insights about the features that we have. So let's run this and analyze our data. So in this case, notice in this case is that we have those columns, and the first thing that we can notice that every one of them have a different type. So D type is the number of columns, the type. So age has an integer type, sex has an object, and this is an object because pandas treat strings as objects. So it can be related to that fact. BMI is a float in that case, and smoker is an object because yes or no, and region as well because the string as well it's an object, and obviously charges are float. Another thing I can notice is that non-null values, some of them have null values. So the BMI index has some fewer values that are non-null. So there are some missing values. We have 1335 and not 1338. So we have 3 missing ones that have nulls inside of them. So we'll have to treat that later on, whether by deleting it or adding some values, specific fake values, so on and so forth. So now, is everyone able to follow up with me? Okay, we can now move to the next part. Okay, another function that's interesting in pandas is describe. Describe will help us generate some statistics about the numerical function features that we have, mean, standard deviation, minimum and maximum, and stuff like that. So it's important because sometimes for example, if we have some very wrong data in the age, for instance, the maximum will show a very, very high number. For example, if someone will have an age of 100,000, it be wrong. So what I know that I need to delete that row and I need to look for this weird data. So that's one way. And to help us understand how the scale of every single value is. So notice here that the age scale is between has a mean of 39, while the children scale has a mean of 1. So something that is very interesting, important that we need to do usually in machine learning is that it's nice and it's usually recommended to make all our features of the same scale and mainly 0 to 1. So we need to squash all the features between 0 and 1 because that will make the algorithm run and train faster and reach its optimal solution faster. So that's something I can get from this describe, and we'll take note of it because we're going to discuss it and do it in a bit. So now we evaluated the data like numerically. Let's start by visualizing the data. So let's look first at the distribution of the charges and help us understand how exactly patients are being paid for insurance based on the frequency exactly. So let's use the histogram function. It's hist. So let's try to run it. And let's see. So what I can see exactly here is that the distribution of charges is quite uneven. It's not uniform between the people, because you have many people that have charges less than to $10,000, and you have very decreasing number of people who have charges bigger than 20,000. And it's kind of obvious. Usually people have some illnesses that are not that expensive, except in like very major cases where they have very dangerous diseases. And that's logical. And this helps us understand that the charges distribution is quite representative of real life. Because let's say we didn't have a quite real representation of the data of the charges of in real life, and we want to do some evaluation on new data, our model will not give accurate results because it was not able to generalize enough and based on the small data and not really represent the data that it had. So that's a very important point to know. Another thing that we can work about here is to figure out the relationship between smoking and custom cost of treatment. Sorry. So what my hypothesis would be is that, let's see your hypothesis before I do that. What would be your hypothesis, the relationship between someone being a smoker and its cost of treatment? You can open your mic if you don't feel like writing it.
Positive correlation.
Yes, exactly. Whenever and my hypothesis as well is similar. We didn't test it yet. So whenever someone would be a smoker, there is a higher chance that its cost will be higher. So let's start by selecting the people from the dataset that are smokers. In order to do that, we will follow a specific syntax in pandas that I will do the first and will ask for the second one. I just want to remember the name of this data. So we'll do is that we're gonna have the data set data, and then inside of it we're gonna select the data that has the smokers will be yes. So what was the name of the smoker column? Check smoker. So inside of the data, I'm going to select the ones that are smoker. So smoker equal yes. Okay, now that I have done this, can anyone give me the example for the non-smoker? How can I do it? It's quite similar.
بس بدل yes بنحط نفس.
Exactly. And it will ask you about them in a bit. Let's generate this one and see. So we have 274 smokers and 1064 non-smokers. So this dataset has this much. So let's try to investigate some correlations now. So let's plot the charges for each one of these. So in order to detect the distribution of the charges for the smokers, we're going to use the histogram again. So we'll this mainly here what I'm doing is literally just giving some helper functions to like generate the plot, and x is just a placeholder for like the axis that I'm going to plot. So x.hist, inside of it I'm going to add smoker, was it non-smokers, but what is the feature that I'm interested to select here? I'm interested to check the distribution of charges of people that are smoking. So it's charges. Similarly, I'm going to copy it. For non-smoker, I will do the same thing. But instead of smokers, I'm going to change it and add non-smokers. So let's run it and see. Okay, so let's take a look to it. So for instance, one thing is that for non-smokers, the maximum that you can get for non-smoker is $35,000 maximum, and it's quite low for that. The average is from 15,000 and below. And this quite tell us that while for smokers it can goes from 20,000 to 60,000. It's quite obvious that smokers feature is very important for the charge. It has a high correlation. So that's one feature that we can keep, and we not believe it's quite important for that. So we're gonna keep it, and that's some interesting analysis that we're going to do. So let's check the correlation between the age now and the cost of treatment. So before we move, let's check if the ages are well distributed. We have a representative of the all ages. So can anyone copy paste the plot histogram in the chat so we check if it's working with you? What it would be in this case? What would be the code that I need to fill here? Anyone? No, we talk about a distribution. So it's a histogram. So plot dot histogram. So hist not really ages, but rather data, and we select the feature that is called age. Age, well, ages. Yes, ages. Let's see. Oh no, age. Oh yeah, it's age. Okay, so we notice here that unless for people who are less than 25 even, the ages are quite uniform. So it's very important, and it's quite representative of a group of population. We're not really sure where exactly this is in the US. The US considered to be a young population, so it's quite representative. So it can really tells us that how representative of the real ages distribution. So that's really important. Let's now move and draw a scatter plot that can shows us the correlation between age and charges. What is your hypothesis in this case? How would be
similar كمان positive.
Yes. So as the age, in my theory is as well. So as the age increase, the charge will be increasing. Yes. So let's plot dot scatter and data. This is the x axis. So data dot age, and the y axis is the charges. So data charges. So let's see. Okay. So let me see. Is it be like that or بالقلب? نوعس لحظة لا let's flip them so data age data yeah I'm gonna test something I need to make sure it's working. Yeah has been a while I didn't do this one so I'm gonna check. Okay that's I'm gonna give you this one, you can use it. So okay, so what I wanted to show you here, and that's why I tried the different flipping them, because is that I wanted to show you that as the age increases, the charges increases, and as you can see, for the people who have lower, are younger mainly, those people have lower costs. So as you can see, as we increase in the age, for every single of these layers, the costs increases. So it's quite a teller that the people here, as they age, their charges increases. So as well, age is a very important factor in the insurance, and it should not be removed. So yeah, so that's another thing. Okay, so with that, then we can move to the next part. So let's check now if smokers, how the relationship between smoking age and cost are all related. So we prepared already this because it's quite thing. So what we're mainly here is plotting is that smokers' age and smokers' charge are plotted in red, and non-smokers' age and non-smokers' charge are plotted in blue. So notice as well that people who are smokers, even though as they increase in their age as well, their charges increases. So it's quite important to understand that they are quite correlated, these three factors. Another thing that's important to talk about is the BMI index. So the BMI index is the body mass index. So it's your weight over your height squared. And we have this very big plot here. So let me check where I'm lying these days. Oh, I guess I'm kind of nearing the overweight. بالhealthy overweight. Nice. Okay. Yeah. Yes, so this will be important to note because we'll be using this now. Notice that it's quite distributed from 12 until 42. And yes, let's first look at the distribution of people that are having the BMI index in this data set. So as well as usual, data BMI.hist as well. Let's plot it. And we notice as well that people that have BMI index that are averaging around 330 BMI index on average. So what is 30? 30 is obese, nearing between obese and overweight. And between obese and overweight, so quite tells about the relationship, the quite tells how the population that we are studying has the BMI. So it's quite important to check as well if it's really representative of the whole data set of the whole population, like the US is mainly as well obese. So it's quite representative should be. So it's very important to analyze this before we move. Another thing is that we need to select the people that are obese and the people that are overweight and the people that are healthy. So I would like to ask you to look how to do it. It's not hard. So we're gonna, as usual, have the data and have data BMI. I'm gonna give the first one to show you. And can anyone tell me what are the minimum of the obese and the maximum of the obese? Yeah, the minimum is 30, and the maximum is 39. Yes, it's important to select this. So the minimum is bigger or equal to 30, and we select, we write and data BMI less than what was it? 39. Less than or equal 39. Okay. Can anyone, given that we have already this ready, can anyone write the overweight one and give it, and someone else give the healthy one as well? Quite literally changing in the numbers only. Okay, so the overweight is literally the smaller than the obese people. Let me check if it's. Are you sure it is exclusively bigger than 24? Yes, yes, it is. Thank you. And what about the healthy? Other than Theodore. Okay. So Patrick is saying it is like that. So let me copy it and add the values. It is bigger than 19 and it is less than 24. So it's inclusive here. And is it bigger or equal to 19 for the healthy? Yes. What? No, it's 18 for healthy. Minimum is 18. So let's run it and see. Sure. So, oh yeah, I remember. Okay, so it's very important to put these inside brackets. So the conditions, we're gonna copy it and give it to you now. And not and, I'm sorry, the ampersand. I got used of using the AND operator in Python to the extent I forgot this operator is different in pandas. Let's check. Yes. Okay, so now we are ready to plot every single one, the distribution of charges for every single group of people that we have. So let's start by the OBs. So we want to plot the histogram as usual. It's plot.hist. We write OBs, and we select the charges. So it is charges. Similarly, for instead of OBs, it's not like that. It's like that. For healthy, it will be instead of obese, it will be healthy, and instead of overweight, obese will be overweight for the overweight. So is overweight, and here it will be healthy. Let's run it. Okay, so by the order of them, it's quite obvious that how was it? Let me check. How can I? Oh yeah. So let's color them. It's not mentioned here, but for the sake of representation, so we're gonna make the OBs as color red, and the color for the overweight will be blue, and for the color of the people that are healthy, it will be yellow. Let's see. Okay, great. So now we can see that the distribution of people that are healthy, their color, their distribution is quite low. So the people and their maximum of payment is 30,000 for healthy people. But as people become over and overweight, so the BMI increases, their expenses increases. So as you can see, the obese people has the highest charges, while the the overweight people has less, and the healthy is as well has less. So again, we can conclude that charges and BMI has a positive correlation. So this is important as well. Should not remove the BMI. Okay, so now we finished the analysis, and you notice we took a long time in analyzing because it's quite important to do so. It's quite important to understand our data before we dig deeper in selecting the model, because as you might have noticed, we noted that there's some features that we can delete, some we should not, for instance. So yeah, so let's go and do the pre-processing. So there are some things that we need to do. So first, we need to deal with missing data. There are some that has nulls inside of it, so we need to remove them. There are many ways to do that. Either we remove the whole row, or is a menu nectar, or we create, or we like base our knowledge. We predict new ones. We fill them with like our analysis, or we fill them with the mean of the column itself, or the median, or even zero, as well. And yeah, is there any question? I heard the mic opening. Okay. So another thing that we need to do is remove unused columns. So there is a region column that was not very relevant. We should convert everything as categorical or strings to numerical ones. And we should normalize, and by normalizing, I mean squashing into the same scale, 0 and 1. And let's do this. So let's check how many missing values are in each column. Obviously, we noted that the BMI the only one has missing values. It has 3. Drop those rows with missing columns. So in order to do that, we'll use the drop and a function, and we need to define which axis. Because we are removing rows, we should define the axis as 0. So let's drop this and check. exactly, we remove those three missing values. Let's check again using data.info to see if there is anything null we didn't remove. Notice that we removed all the 3 rows, so our data is now 1335 instead of 1338. But now there is no nulls, there is no nulls. So that's a good thing, because the algorithm will break if there is some null. Okay, now we'll remove some unused columns. The region feature wasn't very relevant because it's not meaningful in this case. So let's remove it. To remove it, we're gonna use the drop function, and in order to do so, it will accept an array. This array will contain the name of the column, and because we're dealing with columns, we're gonna use the access parameter, and it be equal to 1. And let's check now. Run this and check the head. Notice. Oh wait, what? It wasn't removed. Oh yeah, and let's make data equal data.drop. And let's remove the region function. And yeah, the region function is removed in this case. Okay, is everyone able to follow up with me? Okay, I'm gonna proceed. Okay, so okay, yeah. So I always whenever I want to do something that is on the level of the row itself, I use axis equals 0. While whenever I want to do something that's related to the axis of columns, so it's 1. So notice here that I'm dropping a column, the region column, not a row. So I use axis equal 1. So as let's say here, and notice above in the drop an A, that we used here, I use axis equals 0 because I was removing the rows that contain null values and not columns. So yeah, it's very important to know this difference. Once we do that, we're coming to time. Let's convert now the values that we have as strings to values that are numbers. So the gender, we already prepared this dictionary that maps male to 0 and female to 1. Let's use a special function in pandas. Obviously, let's refer to the things. I'm sorry. Yes.
Get dummies. There's a function that we use sometimes.
What is it?
Data.get dummies.
I'm not hearing you. I'm sorry.
I typed it.
Oh yeah, get dummies is one function that you can use and save. Exactly, can help you remove some stuff. But for like simple cases here, and because I'm interested to show you like a general case, we will be going to use the apply function. Get dummies is very helpful whenever you want to do mapping, one-hot encoding mainly. So mapping things to binary format.
Isn't this one-hot encoding or not?
I mean here.
Yeah.
Yeah, but because we only have 2 classes, they can be mapped by one bit, which is 0 or 1. So that's one hot encoding the class.
Okay.
Yeah, but if we had 3, it will be different. It will be 2 bits. So 0, 0, for instance, 0, 1, and 1, 0. Yeah, but in that case, it will be easier to use get dummies. But yeah, here we're going to use the apply function. So inside the apply function, we're gonna call something called a lambda. Lambda is a type of a function in Python that can be called in a one-liner. So it accepts an input as x, and the body of the function is inside after the 2 dots. So obviously here it's gender x. So what I'm doing here is that for every single element in sex, I'm mapping the value that's male to 0 and female to 1. Let's check the data that we have here. Okay, now the sex became a gender, became a value 1 or 0. So yes. Similarly, we're going to do the same thing for the smoker. So can anyone tell me how can we do it for the smoker, or right on the tab? Map the non-smokers to 0 and the smokers to to 1. I'm sorry. Yes, exactly. It's very similar. We're just going to change the dictionary and we're going to change the feature. What's the problem here? Yeah, it's smokers. Yeah, notice here as well, smokers is between 1 and 0 as well. So the last thing that one of the last things that we need to do is that we need to scale the data, squash it between 0 and 1. One simple way is to get the maximum every single column and simply divide all the values by the maximum. So all the values will be squashed between 0 and 1. So let's get the maximum. A simple way of doing the maximum would be to write data.max. So data.max will give us the maximum for all the numerical ones. We've already done that. And in order to divide every single column by its maximum value, easily it can be done by like data over data max. As simple as that. Okay. Let's see the statistics now. Obviously, all the values are squashed between 0 and 1 now, all of the values. This will help easy our training and make sure that our training converges fast. Okay, before we start our work, we need to separate our data to training and testing data because we train on the training data. We evaluate our data, our model on unseen data, which is the test data. So if you remember, we imported this function when we were using the function when we imported it from scikit-learn. It's train test split. So train test split expect two arrays, x and y, and it requires as well the split. So because we want to give 80% of our data for the training and 20% of our data for the testing, we're going to use the test split to be 20%. So 0.2. I remember, I wonder if it's still called a split. I know. What was it? Sorry. Let me check on documentation. Test size, not test split. Well, which one you need, Patrick? The one that Theodore have sent. It's literally the same, but you have to, instead of smoker, you write smokers inside of the function. I'm gonna send it anyway. Okay, so it's test size. So test size عندنا هو 20% and it's inferred that the train size will be 80%. So let's run. Okay, so obviously the train shape it's way bigger than the test shape. Obviously 80% versus 20%. With that done, we're finally ready to train our model. So we're choosing here a simple model. Of course, you can try multiple models and play with multiple algorithms, but we're going to use the simplest one here, which is the linear regression, which is kind of a way where you're mapping for every single feature some weight and then figuring out how to add them together and get your value. So in order to define our regression model, we already imported it. So linear regression parentheses. And in order to train any scikit-learn model, it always follows the same convention. We use the same model, we add a function called fit, and then fit contains the x train, and what exactly as well, y train. So the data and the label. And once we finish training the model, we will score it. In this case, it will score it based on Euclidean distance between the data itself and the error. So that's an important data itself and the prediction. I'm sorry. So let's see. Okay. So it's showing that. Okay, let me check everything's correct. Okay, showing that the model is giving a score of 0.73. Let me check. Is the score here the Euclidean distance? no, the score here, I'm sorry, you can use to verify if your model is predicting correctly the Euclidean distance. It's a metric that we use, but here the model is using something else. So it's a value squash between 0 and 1. So the model is like 70% sure of its predictions in this case. So yes, so the last bonus feature that I wanted to talk about here is the feature importance. So as I'm telling you, linear regression figure out some importance for every single feature, then sums them تعمل مثل average weighted average functions given the values and outputs for you the charge or the output prediction for this. So let's check the importance for every single feature and see if our analysis اللي ضلينا ساعة عليه is accurate. So obviously, one of the biggest feature importance is smoker. So whether a person is smoker or not has a high impact on the charges. Whether someone has a BMI, the BMI as well has a high impact. The sex does not really have any impact. The age is as well has a very important impact, and the children may or may not be very high importance. So this validates our hypothesis that we spent building in the beginning. So we are sure that our model is not making something wrong, it's not making some wrong assumptions, and we can try multiple models and like evaluate them until we are sure of this. So with that, we finished our coding exercise. I hope you found it helpful, and you can always experiment with it, add your own, look for other models, how to improve it, and much more. Thank you for watching today, and thank you for attending this workshop and for being this proactive with me. And thank you for the robotics board as well for inviting me today as well and inviting Beirut AI.
It was a very good workshop. I hope everybody in the call استفادوا قد ما أنا استفدت كمان. And hopefully we keep on doing great in our future ventures.
Thank you, and the pleasure is mine. Make sure to follow us, our workshops, on Beirut AI, and if you are interested in getting more, make sure to register for our Beirut AI membership program. It has 50% discount for students as well, so it's not a lot, and it's valid for the whole year, and you can access all our events recorded and a special platform as well for discussing with us. So yeah, thank you for this, and I'm going to stop sharing now.
Okay, I'll stop the recording as well.